Rate of change is just describes a relationship paper, pencils. That's writing down what the teacher says. You may have been able to get away with that in the past. I think you'll find as we move along, it's more difficult to get away with that. And at some point, it becomes impossible to get away with not writing things down.
And plus, the research supports that it goes in through your brain and out through your fingertips on paper.
Right.
There's something about that, just that whole process.
All right, so rate of change is a relationship between changing quantities. So for example, we might have miles per gallon. How many gallons do we use for every mile that we go? Or how many miles do we go for every gallon that we use? We might have dollars per pound if you're buying some kind of food. The rate of change of your money has to do with the rate of change of the number of pounds that you buy. So all of these things are describing a rate of change. Meters per second. How far do you go for every second that you run? That's a rate of change. So what we can say, the way we can write that mathematically, is that the rate of change is the change in the dependent variable divided by the change in the independent variable. So the dependent variable is meters. Meters change by 10. The amount of time that we run is 15 seconds. We get the rate of change, we get our speed by calculating the change in the dependent variable divided by the change in the independent variable. Usually, for us, because we like to use x's and y's, usually we're going to say the ROC, rate of change, is the change in y divided by the change in x. That's usually how we're going to describe rate of change. Does this look familiar at all? Change in y divided by the change in x. What does it look like? Where else have we looked at something where it's the y over the x? Yes? Slope. We do the y over the x to find the slope. Rate of change and slope are the same thing. This is the same as slope. The slope of a line is the rate of change of the y variable divided by the change in the x variable. So rate of change and slope are the same thing. So what we're really going to talk about today is different ways that we go about figuring out what the rate of change is. So we good so far? Just the idea of rate of change. Y over the x basically is what it is. All right, let's talk about how we use a table. Now we've done this problem before. We just kind of talked about it a little differently. Let's say my independent variable is time and my dependent variable is elevation. So this is going to be independent, and dependent. And this might describe, if we think back to our math jokes last Friday, the people that were lost in the hot air balloon. Well, that hot air balloon starts, the hot air starts not getting as hot because the administrators aren't talking as much, and the balloon starts going down in elevation. So at time 1, our elevation is 360. At time 2, our elevation is 325. So we're going down in elevation. Time 3, this could be minutes, 3 minutes. Our elevation is 290, and at time 4, the elevation is 255. And we want to find the rate of change in elevation. Well, let's see how this is changing. This is going up by 1. That's going up by 1. Up by 1. What's happening here? It's going down by 35. Minus 35. Minus 35. Well, the y over the x, the dependent over the independent, the rate of change is negative 35 over 1. Just like we found the slope. And we would say this is negative 35, whatever our units are, let's say feet per minute. Let's say this is in feet, and this is our time in minutes. So the rate of change is negative 35 feet per minute. Our balloon is sinking at 35 feet per minute. And this is exactly like slope. And here, our rate of change is constant, which means our slope is constant. Do we remember what kind of function has a constant slope? Someone said something, yes? Linear. This is going to be a linear function. If our rate of change is constant, our function is linear. So if we made a graph of this, if we sketched a graph, our graph would look something like this. It would be a line. We'd be going downhill because our balloon is sinking. So this is how we find rate of change using a table. Just like we found slope before when we were using a table. All right, questions here. Okay. Another way that we'll find slope is using a graph. So let's remember our slope. What's the everyday way that we think of slope? Not as mathy, but how do we think of slope? Yeah? Rise over run. Yes. Well, the rise is change in y. Y tells us the up and down over the change in x. The run tells us how far we're going side to side. The x is the side to side. Change in y over the change in x. Slope, rate of change, same thing. So when we use a graph, let me plot some points on a graph here. So I'll draw a set of axes. And I'm going to say we have 1 point at -1, 2. So that's at -1, 2. And I have another point at 3, 4. Now on a graph that you're given in your homework, you might not have the points, well, you probably won't have the points labeled. So you'll have to look for where the graph crosses the corner of a grid mark, a corner of a square, to get your points. But here, just so we're sure what the points these go through, I labeled them. Well, we need to find the slope. So we're going to count the rise and the run. And I'm going to visualize it like this, just a little triangle. Well, to count the rise, I'm going from here, I'm counting up 1, 2 spaces. 1, 2. So the rise is going to be 2. And the run, I'm going to count over here, 1, 2, 3, 4. I'm just counting across from here, 1, 2, 3, 4, to find my run. So the slope is 2 over 4, which is 1/2. So to find the slope using a graph, you're just counting spaces to find your rise, and you're counting spaces to find your run. The rise is the up, the run is the left or right. Questions there? Hopefully, this counting spaces used finding rise over run is somewhat familiar, maybe ringing a little bit of a bell. Let's look at another graph. I'm going by ones here. 1, 2. And I'm going to have a point here at -2, 4. And I'm going to have a point over here at 2, 1. So my graph that goes through those 2 points is going to, my line that goes through those 2 points is going to look like so. And I'm going to do the same thing to find my slope. I'm going to think about this little triangle that goes like this. And I'm going to count my rise. And I'm going to count my run. So I'm going from here, 1, 2, 3. But to get from this point to this point, I'm going down 1, 2, 3. If I'm going down 3, what am I going to call my rise? -3. Since I'm going down, I call it negative. So it's going to be -3. And my run, 1, 2, 3, 4. -3 over 4. So if I'm going down, my rise is going to be negative. Yes?
Couldn't the one on the top be -2 over -4?
It could be, yes.
Okay.
And -2, so a negative divided by a negative would give us a positive.
Okay.
So it'd come out the same.
Yeah.
If you wrote on a test -2 over -4, I would give you full credit
Okay.
because it's the same thing. When our slope is positive, it means our graph is going uphill from left to right. When our slope is negative, it means our slope is going, or a line is going downhill. Our rate of change is positive, it means we're going uphill. If this were describing our balloon, it'd be getting filled with more hot air, and the balloon would rise. Here we're going downhill. The slope is negative, we're going downhill. The balloon is losing hot air, so it's sinking, going downhill. Positive slope means we go uphill. Negative slope means we go downhill. We good with using a graph? The third way that we'll find slope is sometimes you're not given a graph. All you're given is the points. So we want to be able to find slope just using points. And to do that, we use the slope formula. The slope formula between points. All right, guys, enough with the paper. Between points x1, y1, and x2, y2. So the x and the y are the coordinates. The 1 and the 2 are just saying this is the first point and this is the second point. The slope equals the change in the y. That is y2 minus y1. That tells us how the y changes. Divided by x2 minus x1. This is the change in the y divided by the change in the x. So let's take a look at how we use this formula. So let's say we want the slope between the rate of change if something is moving between these points, slope between -3, 5 and 2, -1. Now we could draw a graph and plot these points and count our rise and count our run. You can do that. It gets a little harder if this were 3,572 and 500,896, and this is 200,485, and this is -1,375,000. It's harder to draw that graph. So what I'm going to do is label my points. x1, y1, x2, y2. It doesn't matter which one you say is 1 and 2, but the 1s have to stay together and the 2s have to stay together. So our slope equals y2, -1, minus y1, 5, over x2, 2, minus x1, -3. Well, -1 minus 5 is -6. -2 minus -3. Minus negative makes it positive. So 2 plus 3 is 5. So our slope would be -6/5. -6/5. So we're going downhill from the point -3, 5 to 2, -1. Yes.
Why is it always y2 over y1 or minus y1?
It doesn't matter as long as you keep them in the same order on the top and the bottom.
Okay.
So you could do y1 minus y2, but then you'd have to do x1 minus x2. So you have to keep them in the same order on the top and the bottom.
Okay.
And then you'd end up, like you said on the other problem, you'd end up with like -2 over -4.
Yeah.
And then the negatives would cancel. Something like that will happen. All right, let's look at one more point just to make sure we have this idea. I'm going to say 2, -1, and 4, 3. I'm going to label my points, and let's say this time I decided to label my points the opposite way. I'm going to call this one x2, y2, and this one x1, y1. Doesn't matter as long as I keep the 2's together and the 1's together. So my slope is going to be y2, -1, minus y1, 3, over x2, 2 minus x1, 4. Negative 1 minus 3 is negative 4. 2 minus 4 is negative 2. Negative divided by negative is positive, and 4 divided by 2 is 2. I can think of that as 2 over 1. So this slope would be 2 over 1, or just 2. Yes?
Would you get the same slope if you did y1, like switch the...
Yes, so let's look at that. So if I did y1 minus y2,
Yeah.
so here I can say y1 is 3 minus y2, negative 1, over x1, 4 minus x2, 2. Well, 3 minus negative 1 is 3 plus 1. I get 4. 4 minus 2 is 2, which is 2, or 2 over 1.
Okay.
So as long as you keep them in the same order on the top and the bottom, you'll get the right answer. Okay? All right, questions? Other questions? Those are very good questions. And they're also where it's the mistake that usually gets made is either mixing the ones and the twos or switching the order on the top and the bottom. Yes. Uh-huh.
Oh, wait, never mind, sorry.
Okay. Homework. This is section 5.1. And there is our homework. And we have little over 10 minutes. Did I get it right?
Are we at 50?
10:50, yes.
We have 6 minutes.
6 minutes.